Hi, and welcome to the 10 square meter workshop. Today I want to design an air cleaning system for the workshop. Oh no, I hear you say. Haven't we got enough of those around? Well, it's true there's plenty of designs out there, but actually most of them have a fatal flaw. I'll explain more about that after this. There are plenty of commercially available air scrubbers, ones that look like this. And I'm sure they work just fine. The trouble is, they're quite large and expected to hang from the ceiling. Many people, and I'm one of them, don't have room for anything as big as this. So, you build your own. But there's a problem. Most involve what are called box fans, such as this, with a filter of some form hung in front of them. There's usually 3 or 4 blades, and the edges of the blades are rounded. They're perfectly designed and efficient for moving air around a room where there's no resistance. However, if you put a filter like this in the way, the situation changes. Why should the air go through the filter when it can go around the outside of the blades? Or indeed, the back pressure means it's not actually pushing very much air at all. What you really need is more blades inside a closely fitting shell, so there's nowhere else for the air to go. What is needed is something like this, a duct extractor. It's used for horticulture and industry to extract air from areas through ducts. It's therefore designed to have a back pressure. The fan has many blades closely fitting inside the tube. This is a 6-inch one, the largest commonly available. It's capable of moving over 400 cubic meters of air per hour. That's the equivalent of moving all the air in my workshop every 4 minutes. That's more than good enough. This particular model has the ability to work at 3 different speeds, just by selecting the appropriate input. So, what's it like in operation? Let's try it out. As you can see, it's blowing quite strongly. It's actually very quiet. Difficult to tell with an auto setting microphone on the camera, but trust me, it's quite quiet. So where am I going to put this? Well, there's space above my doorway that's only home to dross and a few spiders. And the space here to fit the filter. And it's space I won't use for anything else. But hang on, do I really want to take the air from my workshop, push it through a filter and recirculate it back into the shop? Well, yes I do. At least in winter I do. I don't want to lose the warm air that I've just heated. But in summer? Well, in summer I'd much prefer to have nice cool air coming from the outside. So the plan is to exhaust it. So, 2 options. Internal recirculate or external throw away. Best of both worlds. So, what sort of resistance does a HEPA filter of this sort normally exhibit? Well, typically it's about 120 pascals at a rated flow of 400 cubic meters per hour. My fan is rated at 220 pascals at 430 cubic meters per hour. So, ballpark, I'm pretty close. The fact is, a filter like this and a box fan are a hopeless mismatch. Bound to fail. Since each build will be different, I shan't go into too much detail. Suffice it to say, I cut everything out using my MFT, and this is what the frame looks like in the white, as it were. For the diverter valve I used a piece of 10mm rod. I machined a flat and a square end. The end was drilled and tapped 4mm to take a securing bolt. Cut in 2, this makes both ends of the pivot. I chose 10mm because I already had a couple of phosphor bronze bushes in that size from my spares box. These stub axles were then fitted to a piece of aluminium angle, the width of the duct. The aluminium angle is fitted to the bottom of the diverter flap. Here you can see the bottom vent, which will lead to the outside world. This is my hole cut in the workshop to the outside world, now covered with an insect grill. It sits under the overhang for the entrance. As can be seen from this bottom view, the diverter valve closes off the bottom vent and opens up the filter vent. And finally, I get to mount the fan. The handle is made from wood and aluminium with a sliding catch to lock it in position. The filter sits against foam sealing strip and is held in place by simple toggles. Time to install. As you can see, approach access is quite tight. A small 3D printed box holds the switches that control speed and power. It's a really snug fit in there. Not a lot of space to spare. You can currently see it in summer mode. So, how loud is it in the middle of the workshop? Having been professionally involved with audio, I have deep suspicion about decibel meters, but let's give it a go. Low. Let's call it 48. Medium, around 50. High, around 57. My dust extraction system's around 60. Well, the system's in and running now. It looks promising, but I'm not going to jump to any conclusions. I need to mess around a little with the inlet ducting to find the most effective way, and then do some measurements, both of dust and temperature change. But I hope you found this interesting. See you next time.